Okay. Good morning, everyone. Dr. Nat here. So we are continuing. We are not continuing. This is our first lecture, actually. Last class, we talked about like an overview of the course. So today, we're going to talk about overview of an engineering drawing. So what are we getting ourselves into in this course? Okay. Okay, so the content for this lecture is graphics language, engineering drawing, projection methods, orthographic projection, drawing standards, lettering. And some of these we already explored in our lab. Nanti kita akan nampak kejap lagi. Okay, so for graphics language, what is it? So, okay. So effectiveness of graphics language. So look at this object, try to describe how to draw it. So let's say you want your friend to draw this object. How would you describe this object so that they can draw it correctly with the right dimension? So it's quite hard, right? So doing it in written description is hard and sometimes not enough. So we have to use graphics to convey what we want for our friend to draw for us. So you can easily understand that the word languages are inadequate for describing the size, shape, and features completely, as well as concisely. You can, but it's going to be very lengthy. And we don't, as engineers, we don't like to waste time. So graphics is the way to go. Okay, so composition of graphic language. So graphic language in engineering application use lines to represent surfaces, edges, contours of objects. You saw that just now. We see lines over here, and this is to represent the surface and whatnot. This is what it means. Okay, so the language is known as drawing or drafting. So believe it or not, drawing is actually a type of language, even though we don't actually coin it as a language, but for engineers, it is a language. We use it to convey our ideas. A drawing can be done using freehand. This is for conceptual sketch. Instruments, this is like more precise and accurate, or computer methods, which is what we use for like 2022, kita dah pakai komputer lah. Aduh, jarang lah nampak orang yang lukis pakai instrumen yang drawing board tu semua pakai komputer. Sebab easily translate, you have like a third party app where you can just upload the file and you can 3D print it, or it is more nice to see on the eyes lah when you use computers compared to lukisan tangan. Okay, so this is an example of freehand drawing. As you can see here, it's quite okay, but it's not very precise. The lines are not sharp. You can use it, but it's not the best. And this is using instrument, like I told you before, drawing board, using triangles, using rulers, using pencil. You can produce technical drawings like this. Before computer-aided design was used, before AutoCAD was used, before CATIA, before SolidWorks, this is how they did it, using a compass, pencil, a triangle, T-bar, drawing board, stuff like that. And I have to admit, it's quite hard. Even for me, I didn't enjoy it. I like using computer better. Sebab dia ada macam step-step dia nak pakai triangle tu, which I don't like. Okay. So, but you can draw your technical drawings by hand, and there's nothing wrong with it. So here you can see that there is like ada arrow, ada numbers, and you can see that there are 3x, and then there is like symbol bulat ni. What is this? This is called diameter. It's the symbol for diameter. I hope you can see my cursor over here. This is the symbol for diameter, and this R is radius for sure. And you have this method of labeling dimensions. So this is something that we have to learn later on. So kita extend the line, and then baru letak arrow. Extend the line, and then arrow outside if the space is too small, and stuff like that. We will learn later on. Okay, so there is a standard that you have to follow to do technical drawings, because you are basically giving this technical drawing to like architects ke ataupun contractors ke, and sometimes you're not there to explain to them what your drawing means. So they have to understand So everyone has to use the same standard, so we know what we're talking about, okay? So drawings are usually made by commercial software such as AutoCAD, SolidWorks. I believe you know CATIA as well, if you've seen it before. So this is a bicycle made with AutoCAD. You can have a bicycle drawn using AutoCAD. Companies, before they start manufacturing, they draw it 3D like this, and they decide on the design. Okay, so moving on to engineering drawing. So elements of engineering drawing are made of graphics language and also word language. Not too much, but there is some word language that we use as notes. Graphics language is used to describe a shape mainly, while the word language describes the size. We saw the dimension labeling, it was using language, word, ataupun numbers, location, and also specification of the object. For example, we've seen the 3819 over here. This is the word language. The one in red is the graphics language. The one in blue is word language. And you've seen this, what do you call this? Title block. Saya tak ajar itu. The name for this thing and the labeling over here, the box that you made in lab last time, is called the title block. So whenever I say title block, it means to this lah, the template. And you put in your drawing inside the title block. And this square over here will describe your drawing. For example, who is the drafter? Who made the drawing? So this is where you put in your name. What is the scale? Is it 1:1? Is it 1:2? Is it 0.5? So you have to specify the scale and whatnot. Apa yang kita dah tulis hari itulah. Saya tak ingat dah dalam lab tu. Okay, so basic knowledge for drafting. As I mentioned to you before, if you know how to use AutoCAD or similar software, basically you can work with architects. You can work with companies that produce design for other companies. There are some companies that do that. They draft the design for someone. Sometimes they call you as engineers. Sometimes they call you as manufacturing engineer. Sometimes they call you design engineer. Sometimes they call you drafter. So banyak opportunities if you learn this language. So basic knowledge for drafting, you have to know the graphics language, obviously, and also the word language. The word language is lettering. The graphics language is line types, projection method, and also geometric construction. So what is the projection method? If you have any questions, you can ask me. You can interrupt me. So here we have the projection method. I think I'm going to use the slideshow for this one. So projection method, we have perspective and parallel. Ada two types, perspective and parallel. So for parallel, we have the oblique and also orthographic. And for orthographic, under orthographic, we have the axonometric and also multiview. We will learn what these are later on. So again, there are two types of projection method. One is parallel. Parallel means selari. Perspective is yang macam 3D tu lah, nampak macam 3D. Ada angle-angle semua. And under parallel, we have oblique and orthographic. Under orthographic, we have axonometric and also multiview. What is multiview and what is axonometric? Okay, so the projection theory is used to graphically represent 3D objects on 2D media, because we typically print our drawings on paper. So we have to represent our 3D model in the form of 2D media. Atas kertas kan, 2D lah. So to know how to do this, we have to know the projection theory. So the projection theory is based on two variables. Dua benda yang menentukan projection theory, which is the line of sight ataupun LOS, and also plane of projection. Plane of projection. Line of sight and also plane of projection. So what are those? Benda ni kacau saya punya penglihatan. Sekejap dekat atas ni kacau tu. Okay. So LOS ataupun line of sight is an imaginary ray of light between an observer's eye and an object. Again, line of sight is an imaginary ray of light between the observer's eye, your eye, and the object. For example, I'm holding a, oh no, tak nampak saya punya phone. For example, my hand, okay, nampak hand. So now daripada mata saya, so ray of light to the object. So that is the line of sight daripada objek ke mata, mata ke objek. Dia straight line je. So that's your line of sight. There are two types of line of sight, parallel and also converging. The one that I described to you, straight line, that's the parallel line of sight. Converging saya tak perlu nak tunjuk. So how does the parallel projection look like? Hello. So this is your object. So I'm drawing lines from the edges of this object. Okay, I'm drawing lines from the edges of the object. And this is called the line of sight. I imagine that my face is over here. I'm just looking at it parallelly in parallel. So for perspective projection, line of sight dia akan converge. So mata saya kat bawah ni lah. So the edges, the line is, macam nak cakap ni. So the line converges to my eye down here. Here saya imagine muka saya terpampang kat sini. So semua parallel. Sebenarnya tak parallel sangat lah mata kita kan. But so if I'm down here, I can say that the line of sight is converging. Sebab saya nampak benda ni distorted. Kalau saya nampak benda tu distorted, maksudnya perspective projection. Kalau saya nampak benda tu as it is, it's parallel projection. Okay, contoh saya punya tangan. So I'm looking at my hand. I see it as it is. This is parallel projection. But if I put my hand up here, I'm looking at it, the image of my hand is distorted. Maksud distorted ni is kat bawah ni nampak besar, bawah ni nampak besar, kat atas ni nampak kecil. But in reality, I know that my hand is sama size je. But when I put my hand up here, bawah ni nampak besar, the bottom of my hand looks big, but the top of my hand looks small. So dah distorted lah kan. So perspective projection does that. You see a distortion. But dalam brain kita, kita dah tafsir, dah siap-siap, oh sebenarnya tangan ni bentuk dia macam ni. But when I look at it up here, it is distorted. But our brain already process it sebab kita pandai kan. Okay, so that is the difference between parallel projection and perspective projection. Okay, so what is plane of projection? Just now we talked about line of sight. What is plane of projection? Kejap This is an emergency. Okay, tak emergency sangatlah rupanya, sorry. Okay, plane of projection is an imaginary flat line. Flat line, flat plane. Tengok tu distracted je, hancur semua. Okay, plane of projection is an imaginary flat plane. Flat plane plane. Which the image is created. The image is produced by connecting the points where the line of sight pierces the projection plane. Okay, back to the line of sight tadi. Kita dah nampak tadi kan? So again, our line of sight was like this. Ada parallel, ada projection. So now kita nak letak this line of sight on a plane. Plane ni macam paper lah. Okay, so let's look at it. Okay, contoh this is the plane. Boleh anggap plane ni macam paper je lah. You're putting up a paper and you want to map that line of sight. So where does it go? Hello, lambat lah pula. Okay. So now that you have your paper, your line of sight semua dah tembus paper tu, you can draw. So this is parallel projection. You see the object as it is. Okay, what about apa tu tadi? Converging projection? What was it? Perspective projection, sorry. Converging line of sight. So this is our paper ataupun plane of projection. And again, kita punya line of sight converge tadi. So how does it look like? Okay, so as you can see over here, I'm not putting the paper dekat hujung dekat hujung line of sight. Kalau letak paper tu kat hujung tu dapat satu titik je lah. So quite useless to do that. So I put the paper in between that point and the object lah, of course. So what do I get over here? I get a smaller projection of the image. So you know that this is not the object as it is. Dah ada skala kat sini. So distorted lah. Tak adalah distorted sangat pun. Tapi you know, it's not the same size. Okay. So what is the disadvantage of perspective projection? So perspective projection is not used by engineer for manufacturing of parts because it is difficult to create and it does not reveal the exact shape and size. Okay, so this is an example of projection, perspective projection. You look at the road, as you can see over here, the road is bigger here, but dekat hujung ni dia kecil. But you know that the road is supposed to be like a ruler, right? It's supposed to be like all the same size. But because this is a perspective projection ataupun perspective view, it looks distorted. But our brain processes it as, you know, as a regular road lah, walaupun nampak rupa macam ni kan. So perspective projection is difficult to create. Kita kena imagine betul-betul macam mana nak lukis semua tu ataupun kena buat skala tu. And it does not reveal the exact shape and size. For example, I am an alien from outer space and I've not seen a road before. And this engineer, dia cakap, boleh tak buat road dekat Mars? Macam ni. Dia kasih gambar projection. Dia kasih gambar perspective projection. Me as an alien who has not seen a road will construct something that looks like this lah because I don't know how a road is supposed to look like. So sometimes the disadvantage is to people that has not seen the actual object. You only get the drawing as a perspective projection. This is what you're going to work with. So tak membantulah untuk orang yang tak pernah nampak. Another example, this engineer wants to build KLCC. Waktu tu KLCC tak ada lagi. And dia kasih gambar perspektif. So you can imagine gambar perspektif KLCC daripada bawah besar, atas kecil, and let's Google it. Macam mana perspektif KLCC? Buang masa je, tak apa. Kita buang masa sama-sama. KLCC Perspective View. Sekejap nanti saya share screen balik. Okay, I have a good one here. Okay. Share screen. Abaikan tu. Okay, so this is the perspective view that I give the engineers to work with. The engineers pun blur kan, apa benda nak buat ni sebenarnya. There's no measurement. You know, there's no standard being followed here. This is like perspective daripada angle mana-mana entah. So it's not very effective. There's a disadvantage obviously to people who, you know, memanglah KLCC tak boleh nak buat scale 1-to-1 kan. Tapi this is also not very helpful lah, even though it's pretty. So pretty is not the way to go. Always go for standards. Okay, stop sharing. Okay, share balik lecture. Okay, so it does not reveal the exact shape and size. So perspective KLCC kita tengok tadi tu, you can't make up how does the KLCC look like at the top. You don't really know at the back macam mana, dekat front macam mana. You only see like bawah dia kan. It's not very helpful. Okay, moving on. The width is distorted. Okay, so dah habis projection view. We talked about perspective projection and also parallel projection. And we saw that we can put a paper in between the line of sight and we can actually map out the object. So now we're going to talk about orthographic projection. Okay, so what does it mean? Orthographic projection is a parallel projection technique in which the parallel lines of sight are perpendicular to the projection plane. That's a mouthful. Again, orthographic projection is a parallel projection technique. Dia parallel projection yang kita dah tengok tadi tu, in which the parallel lines of sight, are perpendicular to the projection plane, which is the same thing as we saw just now, I think. Okay. Dia kena perpendicular. Nampak Line of sight is perpendicular to the plane. Apa maksud perpendicular? 90 degrees, right angle. So again, this is your line of sight. This is your plane. What's the angle between the line of sight and the plane? 90 degrees. So this is orthographic projection ataupun parallel projection lah. Okay, so object views from the top. This is what we saw just now. And this is from the top of this object over here. So dia buat line of sight daripada atas. Anggap kita punya mata kat atas ni. Apakah line of sight kita? Walaupun plane kita masih kat sini. So dia tarik sini, tarik sini, tarik sini. Projection plane. So orthographic view depends on relative position of object to the line of sight. Let's see what that means. Okay, tengok ni object. This is our plane that we want to map the line of sight. Okay, so this is the front view of this object. And then I rotate it a little bit. And I map it to the plane. 2 dimensions of an object is shown. This one, and I rotate it a little bit, and I map it. I map the line of sight on the plane as well. So saya dapat dua view. So this is called multiview drawing. Just now I told you orthographic view ada multiview dengan axonometric. This is multiview. Multiview is when you have more than one view ataupun 2 views lah. When you have 2 views mapped on the plane, it's called multiview drawing. 2 dimensions of an object is shown. And then you tilt it, you tilt this same object and you map it on the plane. You map the line of sight on the plane. This is what you get, another dimension. 3 dimensions of an object is shown. This is known as axonometric drawing. So again, to summarize here is orthographic view, ada 2 jenis. One is multiview. Multiview is when you have 2 dimensions. The other one is axonometric drawing. It is when you have 3 dimensions. Okay, pretty simple. It's just terms. Okay, what do we have here? Notes. Orthographic projection technique can produce either multiview drawing or axonometric drawing. Both drawing types are used in technical drawing for communication. Typically, kita akan go for 3 lah, axonometric drawing, because it's more complete compared to multiview. Especially if the object is like, ada bulat-bulat lah, apalah, macam-macam kan. So we use axonometric lah most of the time. Okay, axonometric is also called isometric. For those yang pernah ambil lukisan kejuruteraan, I think this word is familiar to you. So axonometric is the same as isometric drawing. The advantage is easy to understand. The disadvantage is that sometimes you have that shape and angle distortion, especially if you have that angle rotation. When you have that angle rotation, dia akan distort a little bit lah. For example, distortions of shape and size in isometric drawing. So you know that this object kat sini is supposed to be a circle sebab brain kita dah proses macam tu kan. But dalam gambar, it's an ellipse. It's not exactly a circle. So that is your distortion. And here, if you measure this angle over here, it's not 90 degrees. But we know that it is a right angle sebab dia bucu kan. This is how our brain processes it. But in this figure, if you measure it using protractor, dia tak 90 degrees lah. Dia, I don't know, 45 maybe. I don't know. Okay, so the right angle becomes obtuse angle. Really? Is it an obtuse? Okay lah. So the right angle is no longer a right angle lah. So there is your distortion. The only way that we survive is that we already know that it is supposed to be a circle. It is supposed to be right angle, sebab bucu, you know, kita dah familiarize with the types of drawing like this. So that is how we process it. But for those yang tak pernah nampak objek macam ni, memang dia tak tahu. Am I getting chat or not? Okay, no. I think it's on my WhatsApp. Okay, any questions so far? Is everyone okay?
So far okay, Doktor.
Okay, Doktor.
Okay, Doktor.
Tak ada apa-apa yang susah kan? Just terms. Rasa AutoCAD lagi susah kot. Okay, so the advantage. So this is now multi-view drawing. The advantage is that it represents accurate shape and size. Tadi kita nampak front dengan dia tak ada rotation, tak ada angle lah. Disadvantage, require practice in writing and reading. Obviously, semua benda pun kena practice. For example, multi-view drawing, two-view drawing, let's see. So this is what you get from that same object. You get the front and the side. So this is multi-view. When we have that angle thing, it's called isometric, the third dimension, right? Okay, so multi-view ni lagi senang to work with lah. Okay, now let's talk about drawing standards. So like I told you before, you have to follow standards, not just make it nice and look pretty. So for each country, we follow a certain set of standards. For example, Malaysia follows, ni Turkish pula. USA follows NC, American National Standard Institute. If you find the word NC, this is what it means. I think you saw it in AutoCAD waktu nak pilih A4 ke A3 ke. I told you guys to pick ISO full bleed A3, something like that. But there was another option called ANSI, ataupun this is what it means, like American National Standard Institute. We always don't want to follow the Americans because they use inches, they use feet. We don't want that. We use the international standard, which is millimeter, meter and stuff like that. Okay, so you know USA dia suka macam ngada-ngada kan. And then Japan is JIS, Japan Industrial Standard. The UK uses BS, not a curse word, British Standard. Australia AS, Australian Standard. Germany is DIN. I'm not gonna pronounce that. And then we have the ISO, International Standards Organization. Kita follow ISO. And also sometimes we call it as MS, Malaysia Standard. Okay, so tapi kalau tak ada jumpa Malaysia as MS, jangan panik, pakai ISO je sebab Malaysia memang pakai ISO all the time. Okay. So going back to the previous slide, saya rasa saya skip tadi. Okay, introduction. Standards are set of rules that govern how technical drawings are represented. So our standards will not be the same as Americans, but American follow standard diorang sendiri. Kita follow international punya. Most countries use ISO unless you know they decide not to, but most of the time most countries pakai ISO. Drawing standards are used so that drawings convey the same meaning to everyone. For example, I'm using English, you are using English, I understand you perfectly fine. But if I'm using English, you're using German language, I can't understand you because our language is not the same. Standard ni part of the language lah, macam grammar. Okay, it's part of the language. So our language here is graphic, the standard is the grammar, so that kita boleh faham apa yang disampaikan dengan tepat. Okay, so drawing standards are used so that drawings convey, okay, already said that before. Okay, ni pun kita dah go over. Okay, partial list of drawing standards. This is an example used by Japan. JIS, Japan Industrial Standard. So here the code number is JIS Z8311. So this means sizes and format of drawing. So let's say the label kat atas tu JIS Z8311, lepas tu bawah dia tu ada content bla 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 macam-macam lah. So you know that this is their sizes and format of drawings. Okay, and not really important for us to remember this, just an example. Of course, we have our own MS, whatever lah. Okay, so where can you get the standards? Companies usually have to purchase them. It's not free. I think IEEE ada kot share some standards, but I haven't downloaded any yet. But I already asked a drafter yang train saya dengan Puan Siti untuk belajar AutoCAD. Dia memang kerja as drafter, so kita orang belajar dengan dia lah. And dia cakap companies selalunya kena beli, it's not for free. So dia tak boleh share dengan kita orang pun because it's not his. So I don't have any MS standards to show you guys. If I can find some, I'll show it to you guys. Okay, so the drawing sheet. What type of paper do we use in engineering drawing? So the one that we used in AutoCAD was A3, but not most of, A3 is my choice. A3 is my choice. Sometimes we can use A4, sometimes we can use A0. A3 was just like an introduction to you guys. Sebenarnya bukanlah A3 all the time. Can use A4, can use A0, A1, etc. Okay, so A4, this is the size of an A4. Contoh, not up to scale. A4 is half the size of an A3. A3 is half the size of an A2. A2 is half the size of an A1. A1 is half the size of an A0. So the A4, A1, A blah blah semua tu, dia ada, it's not like made up randomly. So they are all like half of the next one. Ataupun this one is the big one, this half of this is A1, half of this is A2, half of this is A3, half of this is A4. It's not like on random. But A4 dengan A0 ni agak random lah kot. I don't know which one they started with. Is it A4 or is it A0? I don't know. Hello, kenapa pergi sini? Okay, so here you can see that A4 is 210 times 297. And then the 297 is over here. And then, sorry. This one is double 420. 420 pergi sini, double this guy 594. This guy pergi sini, double 420 841. Lebih kurang lah 840. 841. 841 pergi sini, this guy double dapat 1189. Okay. You don't have to memorize it. I don't remember it too. So the dimensions is in millimeters always. So remember when we started with our AutoCAD, I asked you to set the units. Always set your units to millimeter. That is your ISO. That is the standard. Jangan pakai meter, jangan pakai inches, jangan pakai feet. Always go for millimeter. Okay. So what is the orientation of your drawing sheet? So the title block that you produced last time in lab, was it landscape or portrait?
Landscape.
Sure.
Sure.
Okay, sure. Betul lah tu saja je. So orientation of your drawing sheet, most of the time it's landscape. Not to say you can't use portrait, boleh. Tapi most of the time kita pakai landscape lah. Okay. So this is your title block. This is the borderlines. And inside here is your drawing space, whatever object that you want to portray, multi-view ke, isonometric ke. So this is the place that you put it in, okay? Type Y, A4 only. So for portrait, you can only use A4. Kalau nak portrait, you can only use A4. But for landscape, you can use A0 to A4. Mana-mana boleh. Okay. And last time I told you the border is the same size. Tapi kat sini ada macam besar sikit. Ada besar sikit. Sebab kadang-kadang diorang nak bind. They want to bind the drawings together. So they have like extra space over here. Okay je, nak ada boleh. Nak sama size semua 10 kat tepi ni pun boleh. Nak lebihkan pun boleh. I'm okay with both. But for now, let's just continue using what we have, which is semua sama size border dia. Dia tak ada besar kat sini, semua sama size je. Later on when you doing your project, you can pick. You want it slightly bigger or like smaller ke, tak kisahlah. Sebab dua-dua betul. Ini apa yang saya tutup ni? Title block. Okay. Okay, so the dimension for C, last time kita dah tengok hari tu, was 10. The dimension for C, for our A3, kita buat A3 kan hari tu, was 10. Dalam ni kan, 10. Kita measure pakai AutoCAD punya measure tu lah, it was 10. And if you want your border over here slightly bigger, you can use this 25. Tak boleh buat randomly, kena pakai 25 if you're using A3. If you're using A4, still the same, 10 and also 25. Jangan letak 30, kalau saya measure salah, saya potong markah kat situ. So always use the standard. Okay, measurement is just as important. And then if you're using A4 landscape over here, your D is 25 and your C is still 10. Walaupun dia landscape, walaupun dia portrait, still the same. Here you can see that A1 and A0, the dimension for C is 20. Because why? Because dia besar gedabak. Tengok balik gambar tadi. So A1 dengan A0 besar. So very, very big. So if you have like a border that is the size of 10, that border is like see, kecil sangat. Okay. So for A1 and A0, the border should be this size. All right. Okay, so drawing skills. We've seen drawing scale when we tried to put in text in our AutoCAD drawing. And I didn't explain anything yet about scale, sebab kita belum masuk lecture lagi. But we'll talk about scale in a bit. So drawing skills, scale is the ratio of linear dimension, which is the length or the size. Typically, it's the size lah, of an element of object shown in the drawing to the real linear dimension. Oh, saya annoyed betul dengan benda ni. Dengan Zoom punya. Okay, never mind. Scale is the ratio of the linear dimension of an element of an object shown in the drawing to the real linear dimension of the same element of the object. Panjang gila kan? Okay, what does it mean? Okay, contoh. The size in drawing is like this. Ni yang korang lukis. Tapi yang sebenarnya dia besar. So macam mana kita nak tentukan scale dia? So sometimes you have that scale 1 to 1. When you have a scale of 1 to 1, it means that your actual size and the drawing is the same. But most of the time kita tak boleh dapat 1 to 1 kan? So how do we do this? How do we use the scale? So here they measured one side of this object and they measured this one side of the actual size and they comparekan. So the scale is, I would say that this is 1 to 2. Let me use my pen. Is it working? It is not working. See, okay, now it's working. Okay, so contoh. This is like 10 millimeter, but the actual size is 20 millimeter. This is just the one side of the object. So I know that 10 ni is half of 20, right? So I can say, okay, this is 1 and this is 2. Skala 1 ke 2 ataupun 1 to 2. 1, 2, 2. This is how you say it ataupun this is how you write it. 1, 2, 2. Bendalah ni 2. Okay, 1, 2, 2. So jangan confuse. So this is 10 millimeter and this is 20 millimeter. This is 1, 2, 2 sebab yang ni 1, yang ni kalau ni darab 2 dapat benda alah ni. Kenapa saya cakap actual drawing ni 2? Kenapa saya tak cakap dia 1? For example, I want to say this 20 millimeter is 1. So if this guy is 1, what should be my size in drawing over here? Anyone? What should it be?
0.5?
Half ataupun 0.5, yes. 0.5 to 1. Tapi kenapa saya tak tulis macam ni? Because Scale usually uses round numbers, round numbers. Unless macam memang tak boleh nak round dah, baru diorang akan bagi korang pakai decimal points. But most of the time, you have to use like the round numbers. So if I were to see this scale, I try to make it better into round numbers. So macam mana saya nak jadikan dia round number? Untuk jadikan benda Allah ni round number, I times it with 2. If this guy has to be times by 2, then this guy also has to be times by 2. So this becomes 1, 2, 2. So it's basically the same thing, it's just how you write it. But the correct way is to use round numbers lah. Okay. Okay, so designation of a scale consists of the word scale. So when you are implying a scale, they ask you to write it down. Scale. Tulislah scale kat tepi tu. Scale. Scale 1 to 2. Tulislah lawa lah. Scale 1 to 2. So scale 1 to 1 for full size. Drawing 10 mm, actual size pun 10 mm. Scale X to 1 for enlargement of scales. For example, scale of 2 to 1. Masuk kat sini, actual size saya adalah 10. Actual size adalah 10 mm. Tapi saya draw jadi 20 mm. Boleh je. You want to enlarge it so that the engineer can see it better. Boleh. Sometimes you want to reduce it. For example, the one that we saw just now was 1 to 2. Our drawing is smaller, but our actual size is bigger. Contohnya 10 mm. Sorry, kita nak tentukan sama je kan. Objek kita 10 mm. So, kalau scale saya 1 to 2, then my drawing would be 5 mm. Okay. Dimension numbers shown in the drawing correspond to the true size of the object, true size. And they are independent of the scale used in creating that drawing. Okay, what does that mean? Let's go back to this one. Ada gambar tadi. Jauh tak gambar tu? Okay, for example, scale saya kat sini. Saya tulis scale. Contohnya 1, 2, 3. 1, 2, 3. So I know that my actual object is bigger than the drawing. My drawing is small lah. Benda ni besar sepatutnya lah. Okay, my scale is 1, 2, 3. But when I look at this picture, I see it's 38, 19. The radius is 9.5. The radius is 7. Does it mean that I have to multiply by 3 to get the actual size? No. What you see here is the actual dimension. So if I were to draw this, if I were to manufacture this, the actual size is actually 38. The actual size is actually 19. Dalam gambar ni, kalau korang pakai ruler, it's not actually 38. Dia 38 bahagi 3 dalam gambar. Tapi kita letak actual. This is the actual number. Drawing sahaja yang ikut scale. Okay, I'm going to repeat myself here. When you have a scale that is not 1 to 1, dia 1 to 3 ke, 2 to 1 ke, whatever, the drawing is according to scale, but the dimension labeled is always the actual dimension. Okay, so when you label your AutoCAD drawing, remember, look at the question, use the exact number. Jangan pandai-pandai ikut scale pula. Number kena sama. Okay. Dah cakap pasal exam dah. Takut tak? Saya tak buat lagi pun soalan. Okay. What else? What time is it? We have 10 minutes. Okay, I'm going to go for another 5 minutes and then kita akan wrap up lah. Kita habis kat mana tadi? Okay, kat sini. Scale. Okay, so I'm going to introduce to you guys different types of lines. So here we have continuous thick line. This is the line used to draw our objects on AutoCAD. Continuous thick line is used to draw our object. Continuous thin line is used for dimension, for extension, for leader line. Kita akan belajar what these lines mean. And then for dash thick line, it is supposed to be a hidden line. Benda yang tak sepatutnya ada dekat kita punya objek tu. Kita letak dash, maksudnya dalam bila kita manufacture, benda tu tak wujud lah. Chain thin line. is a center line. Kita akan belajar juga what that means later on. Visible lines represent the features that can be seen in the current view. Contohnya, saya ada cube. This is my visible line. Yang merah ni lah, walaupun buruk, visible line. Hidden lines represent features that cannot be seen in the current view. Macam mana tu? Sekejap, saya kena berusaha lukis lawa sikit lah. Dah lah saya lecturer kelas AutoCAD. Lukisan buruk-buruk pula. Okay, sekejap Inilah terbaik saya boleh buat dalam masa 10 saat. Okay. Ya Allah, buruknya. Okay, so that is my hidden line. Benda yang saya tak nampak in my current view. Jadi kalau saya pusing kotak ni, saya nampak lah. But in my current view, I cannot see it. So, apa yang saya buat? Saya lukis dash line to represent the hidden lines. So that my engineer, the one that is constructing this object, knows belakang tu, oh ada juga belakang ni rupa-rupanya. Bukanlah kosong je. Okay? And then center line represents symmetry, path of motion, centers of circle, axis of symmetrical parts. I'm going to give you an example later on, not today. Dimension and extension lines indicate the sizes and location of features on a drawing. We saw just now, kita extend line macam tu, and then kita label. This is the dimension and extension line. 8 mm contohnya. Okay. So again, we talked about visible line. It means that the lines that we see on an object in our current view. Hidden lines is the lines that I don't see in my current view, but it's there. It's there. And center line kita akan belajar kemudian. Dimension and extension lines is the one that we saw earlier on. Yang tunjuk dimension tadi itulah. Dimension and extension line. This one. This is the extension line, the straight line. And this is your dimension line, yang arrow tu. Okay, so I think that's it for today. We're going to continue with our lab on Tuesday. Okay, activity 1 and activity 2 harapnya semua orang dah siap because you know it was due in 3 days. Activity 3 not yet, but if you can start if you want. Assignment kita akan it's not due yet. Okay, so any questions before I end class? Everyone's okay?
So far okay, Doktor.
Okay. Have a
Okay,
great
Doktor.
and jangan lupa lunch. Bye-bye. Take care.
Thank you, Doctor.
Thank you, Doktor.
Thank you, Doctor.
Thank you, Doctor.
Bye.
Thank you, Doctor.
Thank you, Doctor.